Hello everyone, my name is Rahul Kormakar and the title of my paper is Formal Verification Techniques, Comparative Analysis for Critical System Design and paper ID is 27. So these are the content of my presentation. I'll start with what is formal verification, then the contribution of our paper, then study on existing techniques like Z notation, B method and event B, then comparison on different parameters, then why event B is superior than other methods, then future research directions, and followed by conclusion and references. So what is formal verification? Formal verification is very useful for verifying hardware and software systems. Formal methods specify the system requirements. It verifies the model and proves the requirement properties. This is nothing but the blueprint of a software like other traditional engineering. It ultimately reduces the testing time of the software. The contribution of the paper. This paper presents an in-depth elaboration of some formal verification techniques like Z notation, B method and event B. It also presents a taxonomy of the formal methods in critical system design. The specifications are compared with the help of a simple case study. So we shall start with Z notation. Z notation is very powerful formal method for system level modeling. It is based on discrete mathematics, and while a large and complex system design, the refinements are supported using Z notations. There exist some tools for verify the Z notation. These are ZAVS and CZT tool, and it is basically a schema based approach for designing a system, and the schema will look like this. At the right hand side you can see all the variable declaration, all the invariants, and precondition and post condition can be defined using schema calculus. The next formal method that we studied in our paper is B method. It was invented by J.R. Avriel. It is basically an abstract machine model of a system. Of course, it is refinement based, and the mathematical foundation of this language is set theory and predicate logic. And most important thing, basically for automatic code generation or controller is, or the software part is being designed using B method, and the tool supports are available like ProB, Atelier B, like this. And the typical abstract machine model of B method is represented at the right hand side. See, the first one is the basic properties of an abstract machine. See, machine, sets, constant, properties, variable, invariant, and second diagram is for the refinement. That means one machine can be refined by another for the higher level of system design. The next formal method that we are going to discuss is event B. Event B is a formal method for system level modeling and analysis. It is also proposed by J.R. Avriel in 2010. The main philosophy of this method is think a lot before coding, or step-by-step design of a system. Event B notations are based on set theory and predicate logic. Event B has mainly two components, context and machine. The static part of a system is designed using context, and the dynamic parts are designed using machine. A context typically contains sets, constants, axioms, theorems, and machine contains the state variables and invariants are the properties of the state variables. And most important thing in event B is events. This is nothing but the state change of a system, and for any event to be occurred for any parameter, first some precondition have to be checked, and these conditions are called guards in event B, and after satisfying the guard condition some actions are performed, and there is a relationship between machine and context. So here M stands for machine and C stands for context. In case of event B, we start the system design with minimum requirement and gradually we incorporate more and more requirement. See, at the very beginning or the initial level, suppose M0 and C0 is designed, the machine can see the context, so that's why you can see that M0 sees C0 is there. And in the next level, that means we add more requirement of the system, and for that we have different machine and context, say M1 and C1. See, M1 refines M0, that means in the successive levels the machine and context can incorporate the previous properties of the system. That's why M1 refines M0 and C1 extends C0. So this relationship holds for throughout system design. So the tool support for event B. So the rigorous open development environment for complex system, or in short RODIN, is the tool support for verifying the event B notations. It is an Eclipse based open source IDE, and basically we generate proof obligation using this RODIN. So after the in-depth elaboration of ZB and event B, we compared them with some parameters like safety critical requirements. For designing a system, suppose we are designing the system with Z notation, then all the safety critical requirement has to be specified using invariant properties, and this is true for B and event B also. And the next parameter is operation. For any operation to be performed using Z notation, different conditions are used. For B methods, precondition with predicates are used, and for event B, events with guards are used. And as far as refinements are concerned, it is been supported by Z, but in case of B it weaken the model, and for event B is strengthen the model. And for proof obligation parameter, for Z notation it is auto generated. For B method, most of them are automatically generated, sometimes we have to generate it manually. And for event B, it's simpler than B and it is generated automatically and interactively. Like this, different other parameters like function parameters, modeling, programming construct, fairness assumption, key components, temporal property, software design, model validation, tool used, animated tool and plugin support. On these parameters, these three formal methods are compared. We also summarize all the tools or the tool support available for this technique, like for Z notation, ZWord, CZT, JDBS. These are the tools available for Z notation. For B, Pro B, Atlas B. For event B, we have RODIN. So these are all summarized or analyzed by our. So after analyzing these three formal methods, we can easily say that event B is superior than Z and B, and if I say why event B, then we can say design using event B, we can design the static part and the dynamic part of a system individually or separately. It helps to design the whole system effectively by step-by-step design. Large and hybrid system can easily be handled using event B. And finally, event B is relatively new, but it has gained significant acceptance in a very. So in the conclusion, we can say that we have categorically investigated some of the formal specification languages, like as we mentioned B, Z and even B, with their applications in critical system design. The study helps to understand the evolution of formal methods and their use in critical verification over the years. The industry use of B is nearly 30% and gradually increasing, but it gained exposure in industries in recent years. We can say different qualitative and quantitative parameters are also compared in our paper. Finally, this paper presents systematic knowledge about the present state of the art formal methods, and these are the references. Thank you.